Long before cities rose from the plains and before agriculture bound humanity to the soil, our ancestors moved through a world that was not built for them. A world where the night belonged to predators, where every shadow could conceal death, and where survival meant understanding that humans were not hunters alone, but prey. For millions of years, early humans and their hominin relatives walked landscapes ruled by creatures designed by evolution to kill. Cats with fangs like daggers, birds with talons built for tearing flesh, reptiles that could swallow a child whole, and bears that stood taller than any human and crushed bone with casual efficiency. These were not the distant threats of myth or legend. They were the daily reality that shaped our evolution, carved fear into our DNA, and forced our ancestors to become something more than vulnerable primates wandering the African savanna. This is the story of the predators that hunted us, the evolutionary experiments in killing that saw early humans not as masters of nature, but as meat. From the time the first hominins descended from the trees until the moment we developed weapons capable of turning the tables, our species lived under constant threat from animals that were faster, stronger, and far better armed. These predators didn't just kill our ancestors, they shaped how we think, how we organize ourselves, how we use fire, and why we feel an ancient dread when we hear something moving in the darkness beyond the campfire's glow. This is not a story of human dominance. This is a story of survival against overwhelming odds, of prey that refused to accept their place in the food chain, and of the hidden evolutionary arms race that turned terrified apes into the planet's most dangerous species. Dinofelis, the specialized hominin hunter. In the dim light of Pleistocene Africa, a killer moved through tall grass with the precision of a guided missile, and early humans were its target. Dinofelis wasn't the largest cat that ever lived, nor the fastest, but it was something far more dangerous. A predator that had spent millions of years perfecting the art of killing primates. This medium-sized cat, standing roughly the height of a modern leopard, but built with the muscular density of something far heavier, possessed adaptations so specifically tuned to hunting hominians that paleontologists have nicknamed it the false saber-tooth and the specialist. Its fossils appear consistently alongside hominin remains across multiple sites in South Africa, creating a pattern so clear that scientists can reconstruct exactly how it killed. A suffocating bite to the throat, delivered with surgical precision after an explosive ambush. The skull of Dinofelis tells the story of its hunting strategy. Unlike the exaggerated canines of true saber-toothed cats, Dinofelis had shorter, stouter fangs, designed not for slashing, but for gripping and crushing. Its jaw muscles attached to enlarged skull crests, providing devastating bite force focused on a narrow killing zone, the neck and throat. When a Dinofelis attacked, it didn't chase its prey across open ground or engage in prolonged struggles. Instead, it used stealth and explosive power to close distance in seconds, then clamped down on the windpipe or major blood vessels with a grip that couldn't be broken. Death came through asphyxiation or catastrophic blood loss, often within minutes. The efficiency was terrifying. What made Dinofelis particularly dangerous to early humans was its preferred habitat and hunting territory. Fossil evidence shows it thrived in mixed woodland and savanna environments, exactly the transitional landscapes where early hominins foraged for food, gathered plant materials, and searched for water. These were the spaces where Australopithecus and early Homo species were most vulnerable, caught between the safety of trees and the openness of grasslands. Dinofelis exploited this vulnerability with devastating effectiveness. Its limb proportions reveal an animal built for short, powerful bursts rather than sustained running, suggesting it relied on cover and ambush rather than pursuit. It would wait near water sources, game trails, or fruiting trees, then strike when hominins moved through predictable patterns. Cave deposits from sites like Swartkrans in South Africa provide direct evidence of Dinofelis predation on early humans. Hominin skulls show puncture marks that match Dinofelis tooth spacing with chilling accuracy. The size and placement of these wounds demonstrate that the cats targeted juveniles and smaller adults, dragging their kills into rocky shelters or caves where the bones accumulated over thousands of years. Some skulls show signs of being gnawed and processed, indicating Dinofelis consumed its hominin prey methodically, breaking bones to extract marrow and stripping flesh with specialized conceal teeth. These weren't opportunistic kills, they were systematic predation. The relationship between Dinofelis and early humans created an evolutionary pressure cooker. Hominins living in Dinofelis territory couldn't simply outrun or outfight their predators. The cats were too fast, too strong, and too well armed. Instead, survival required behavioral innovations. Group cohesion became essential. Isolated individuals were easy targets, but larger groups could pose sentries and mob attackers. Fire, once mastered, became a defensive barrier that Dinofelis instinctively avoided. Tool use allowed hominins to create weapons for defense and to butcher large carcasses quickly before predators arrived. Every behavioral trait that made later humans successful may have been forged in the crucible of Dinofelis predation. The hunting strategy of Dinofelis also reveals something crucial about early hominin vulnerability. Unlike modern humans, our ancestors lacked effective distance weapons, couldn't run particularly fast, and had limited climbing ability once they became more terrestrial. They were essentially defenseless primates wandering through landscapes filled with specialized killers. Dinofelis capitalized on every weakness: slow movement through tall grass, predictable foraging patterns, the need to approach water sources in open areas, and the vulnerability of young hominins who couldn't keep pace with adults. The fossil record suggests that in some regions, Dinofelis predation may have killed a significant percentage of each hominin generation, creating intense selection pressure for any trait that improves survival. By the late Pleistocene, Dinofelis disappeared from the fossil record, likely outcompeted by more generalized predators like leopards and lions, or perhaps driven extinct by changing climates and shifting prey populations. But its evolutionary legacy persisted in the creatures it once hunted. Modern humans retain deep-seated fears of large predators, particularly those that hunt at dawn and dusk, exactly when Dinofelis was most active. We organize ourselves in groups partly because our ancestors who stayed together survived while isolated individuals became cat food. We control fire and build barriers not just for warmth, but because our ancient relatives learned that walls and flames kept the night hunters away. Dinofelis may be extinct, but the evolutionary shadow it casts still shapes human behavior millions of years after the last individual stalked through African grasslands hunting the vulnerable primates that would one day rule the world. Smilodon, the ambush predator of the Americas. When early humans crossed into the Americas roughly 15,000 years ago, they entered a continent ruled by one of the most iconic predators evolution ever produced, Smilodon, the true saber-toothed cat. This wasn't the medium-sized specialist that had hunted African hominins. Smilodon was a massively built ambush killer designed to take down prey far larger than any human. With canine teeth extending 7 inches beyond the gum line, a body as heavy as a modern lion despite being shorter in length, and forelimbs built like grappling hooks, Smilodon represented the pinnacle of the saber-tooth design, a predator so specialized for killing large megafauna that it seemed invincible. Yet for the humans who encountered it in Ice Age America, Smilodon was a deadly threat that forced immediate behavioral adaptation or extinction. The anatomy of Smilodon was a masterpiece of predatory engineering, but also a study in evolutionary trade-offs. Those massive canines, flattened, blade-like, and serrated along the edges, were designed to deliver devastating slashing wounds to the throat and abdomen of large prey. Biomechanical studies show that Smilodon couldn't bite with the crushing force of a modern lion. Its skull structure wasn't built for that. Instead, it is killed through precision and blood loss. After using its powerful forelimbs to wrestle prey to the ground and pin it in place, Smilodon would open its jaws to an angle exceeding 90 degrees and drive those sabers deep into soft tissue, slicing through skin, muscle, and major blood vessels. Death came through hemorrhage and shock, often within minutes, as blood pressure dropped catastrophically. But these spectacular weapons came with significant limitations. The sabers were incredibly fragile relative to their size, thin blades of tooth enamel and dentin that could fracture if they struck bone or if prey struggled violently during the killing bite. Fossil evidence shows many Smilodon individuals with broken or damaged canines, some of which show signs of infection or incomplete healing. A Smilodon with broken sabers was a Smilodon facing starvation. This vulnerability meant the cats had to be extraordinarily careful during kills, targeting only the softest tissues and avoiding any scenario where their teeth might impact hard surfaces. It also meant they needed to subdue prey completely before delivering the killing bite, a requirement that shaped their entire hunting strategy. Smilodon's body reflected this ambush and wrestle approach to predation. Its forelimbs were disproportionately muscular compared to modern big cats, with massive shoulders and shortened lower legs that sacrifice speed for raw power. These weren't the limbs of a pursuit predator that chased down fleet-footed prey across open plains. Instead, they were the limbs of a wrestler designed to grab, hold, and immobilize struggling animals while the killing bite was delivered. The hind limbs were also relatively short and powerful, providing explosive leaping ability over short distances, but little endurance for sustained running. Smilodon hunted from cover, using dense vegetation or broken terrain to approach within striking distance before launching a short, overwhelming attack. This hunting style meant Smilodon preferred specific environments: woodlands, forest edges, and brushy river valleys where large herbivores congregated and where ambush opportunities were plentiful. These were exactly the same habitats early human populations in the Americas exploited for hunting, foraging, and water access. The overlap was inevitable and dangerous. Paleo-Indian sites across North America show evidence of humans and Smilodon sharing landscapes for thousands of years, creating a predator-prey dynamic where humans were simultaneously hunters of large game and potential prey for the continent's apex ambush predator. The difference was that humans could think strategically, use fire, and coordinate group defenses, advantages that primates in Africa had already been refining for millions of years. Evidence of direct Smilodon predation on humans is difficult to establish definitively because Smilodon preferred much larger prey: giant ground sloths, young mammoths, bison, and horses. Humans would have been small, unpredictable targets that fought back with weapons and fire, making them less desirable than a massive herbivore that could feed the cat for days. However, the absence of direct evidence doesn't mean safety. Opportunistic attacks on isolated humans, particularly children or injured individuals, would have been entirely within Smilodon's capabilities. The psychological impact of living in Smilodon territory would have been profound, knowing that the dense vegetation concealed predators powerful enough to kill a horse created constant vigilance and shaped human settlement patterns, movement strategies, and social organization. The extinction of Smilodon, roughly 10,000 years ago, coincided with the disappearance of most large megafauna in the Americas, an event that involved both climate change and human hunting pressure. As giant ground sloths, mammoths, and other massive herbivores vanished, Smilodon lost its primary prey base. The cats were too specialized to switch effectively to smaller, faster prey that required pursuit rather than ambush. Their short limbs and heavy builds made them poor marathon runners, and their fragile sabers were ill-suited for tackling agile animals that could twist and dodge. Without the slow-moving megafauna they had evolved to kill, Smilodon populations collapsed. Humans, meanwhile, adapted by shifting to smaller game, increasing plant food consumption, and developing new hunting technologies. The specialist died while the generalist thrived, a pattern repeated throughout evolutionary history. Haast's eagle, death from above. In the isolated islands of New Zealand, evolution produced a predator so audacious in design that it seems lifted from mythology, a bird powerful enough to kill humans with a single strike from above. Haast's eagle wasn't just the largest eagle that ever lived. It was a flying apex predator that hunted flightless birds the size of ostriches, and when early Maori settlers arrived, began targeting the most vulnerable new prey item in its territory, human children. With a wingspan exceeding 3 meters and talons as long as tiger claws, Haast's eagle represented an evolutionary experiment in aerial predation that reached its absolute limits. A bird so large and powerful that it pushed against the physical constraints of flight itself, creating a hunter that struck with the force of a cinder block dropped from a rooftop. The evolutionary story of Haast's eagle is one of ecological opportunity and rapid adaptation. Its ancestors arrived in New Zealand as much smaller raptors, probably from Australia, and found islands completely lacking mammalian predators. In this predator-free environment, flightless birds exploded in diversity and size. The moa, a group of massive ratites, filled the ecological niches that mammals occupied elsewhere, some species growing to 3 meters tall and weighing over 200 kilograms. This was an enormous potential food source, but it was also heavily built, powerful, and capable of delivering devastating kicks. Hunting moa required a predator unlike any eagle that had existed before, not a bird that snatched fish from rivers or grabbed rabbits from fields, but a flying killer capable of delivering fatal trauma to prey far heavier than itself. Haast's eagle evolved to meet this challenge by becoming a biological missile. Its body mass reached 15 kilograms or more, roughly double the size of the largest modern eagles, with females significantly heavier than males. This massive size created flight challenges. Taking off required powerful wing beats and favorable winds, and sustained flight at cruising altitude was energetically expensive. But Haast's eagle didn't need to soar for hours like condors or patrol vast territories like golden eagles. It hunted from elevated perches in forest edges and clearings, waiting until moa moved into open areas, then launching a short, steep dive that converted altitude into devastating kinetic energy. By the time the eagle struck, it was traveling fast enough to drive talons completely through a moa's body cavity. The talons themselves were killing tools of extraordinary design. Each foot carried 4 talons, with the rear talon especially enlarged and curved like a meat hook. These weren't the grasping feet of fish eagles or the crushing feet of harpy eagles. They were piercing weapons designed to penetrate deep tissue and sever major organs. When a Haast's eagle hit a moa, the impact alone could break bones and cause massive internal trauma. But the talons ensured that even if the initial strike didn't immediately kill, the prey would bleed out quickly from punctured organs and severed blood vessels. Fossil moa skeletons show pelvic bones with talon punctures, indicating the eagles specifically targeted the lower body, where vital organs were relatively exposed, and where a solid strike would cripple the prey's powerful legs. The hunting strategy was brilliance refined through thousands of generations. Haast's eagles nested in forest canopy or on cliff faces overlooking moa feeding grounds, river valleys, forest clearings, and alpine meadows where vegetation was low enough for the flightless birds to move freely. From these vantage points, the eagles could observe moa behavior, identify vulnerable individuals, and time their attacks for maximum effectiveness. Once a MOA was selected, the eagle would launch silently, using gravity to build speed while adjusting its trajectory with minimal wing beats to avoid detection. The strike came from behind or above, targeting the back, pelvis, or neck, anywhere the talons could penetrate without encountering heavy skeletal armor. The impact generated forces equivalent to a human being hit by a car, often killing instantly through shock and trauma, even before blood loss became a factor. When Polynesian settlers arrived in New Zealand around 700 years ago, they encountered an ecosystem that had never experienced human predation, and a predator that had never encountered humans. The Maori brought with them ecological disruption, hunting pressure on moa, habitat modification through fire, and the introduction of rats and dogs. But they also represented a new prey type, and Haast's eagle adapted its hunting strategies accordingly. Maori oral traditions preserve detailed accounts of puakai, giant eagles that attacked humans, particularly children and smaller adults. These weren't mythological exaggerations. A Haast's eagle that had learned to hunt moa calves weighing 30 to 50 kilograms would have seen a human child as well within its prey size range, and the hunting strategy would have been identical. A silent approach from above, followed by a strike targeting the head, neck, or back. Archaeological and paleontological evidence supports these accounts. Human remains from early Maori settlements occasionally show trauma patterns consistent with large raptor attacks. Puncture wounds to the skull, crushed vertebrae, and evidence of bodies being moved post-mortem, possibly by eagles attempting to feed or cache their kills. The psychological impact of living under threat from aerial predators would have been profound, influencing settlement patterns, child supervision practices, and cultural attitudes toward forests and open spaces. Unlike ground-based predators that could be deterred with fire or barriers, Haast's eagle struck from above with virtually no warning, turning the sky itself into a source of danger. The extinction of Haast's eagle followed swiftly after human arrival. Within 3 centuries, both the eagle and its primary prey, the moa, had disappeared from New Zealand. Humans hunted moa to extinction, eliminating the food base that sustained the giant raptors. Without moa, Haast's eagle couldn't survive on smaller prey. Its massive body required enormous caloric intake, and switching to forest birds or introduced rats would have been like a lion trying to sustain itself on mice. Additionally, humans likely killed eagles directly, both in defense and to eliminate a predator that threatened children. The combination of prey-based collapse and direct persecution proved insurmountable for a species that had never faced such pressures. The last Haast's eagles died out roughly 500 years ago, ending one of evolution's most dramatic experiments in avian predation, and closing a chapter where humans, for perhaps the last time in our history, were genuinely prey to a bird. Cave hyenas, pack hunters of Pleistocene Europe. In the frozen twilight of Ice Age Europe, where glaciers advanced and retreated across landscapes dotted with mammoth herds and Neanderthal camps, a predator prowled that combined intelligence, strength, and social coordination into one of the most dangerous hunting machines early humans ever faced. The cave hyena wasn't the spotted hyena's direct ancestor, but rather a closely related species, Crocodylus spelaea, that had adapted to European climates and developed hunting strategies specifically refined for Pleistocene megafauna. These weren't scavengers skulking at the edges of lion kills. They were apex predators that hunted in coordinated packs, capable of bringing down adult horses, young woolly rhinos, and, when opportunity presented itself, early humans isolated from their groups or sheltering in caves that hyenas had already claimed. The cave hyena was built for endurance hunting and bone-crushing power. Adults weighed up to 100 kilograms, substantially larger than modern spotted hyenas, with massive skulls housing jaw muscles capable of generating bite forces that exceeded those of contemporary lions. Their teeth reflected a diet that included not just meat, but also bone, thick, conical premolars designed to crack open long bones and skull vaults to extract marrow and brain tissue that other predators couldn't access. This dietary flexibility gave cave hyenas a critical advantage during harsh Ice Age winters when prey was scarce. While obligate carnivores struggled during lean periods, cave hyenas could subsist on frozen carcasses and bone marrow long after other predators had abandoned kills. Pack structure in cave hyenas mirrored that of modern spotted hyenas. Female-dominated clans with complex social hierarchies, communal denning, and cooperative hunting strategies. Fossil evidence from hyena dens shows accumulations of bones from multiple prey species, including remains transported over considerable distances, indicating organized pack hunts where different individuals played specific roles. Some members would chase prey toward ambush points, others would flank and cut off escape routes. Still others would deliver the killing bites once prey was exhausted or cornered. This level of coordination required communication, memory, and social learning, cognitive abilities that made cave hyenas formidable opponents for early humans competing for the same resources. The caves themselves became battlegrounds in the relationship between humans and hyenas. Both species required rock shelters for protection from weather, for raising young, and a strategic basis for territorial control. Across Europe, archaeological sites show evidence of repeated occupations by both Neanderthals and cave hyenas, sometimes simultaneously in different chambers of the same cave system, sometimes in alternating periods where one species would displace the other. Human remains found in hyena dens show clear signs of carnivore modification, bones gnawed, crushed for marrow, and scattered in patterns identical to hyena processing of other prey. Whether these humans were killed by hyenas or scavenged after death from other causes remains debated, but the evidence is unambiguous. Cave hyenas consumed human flesh and processed human bones exactly as they did horse, bison, and deer. Direct predation likely focused on vulnerable individuals, children, elderly, sick, or injured adults caught outside the protection of their groups. Neanderthal hunting parties, when returning to camp after dark or in deteriorating weather, would have been particularly at risk. Cave hyenas hunted predominantly at night and dawn, using darkness as cover for approach and ambush. Their eyes were adapted for low-light conditions far superior to human night vision, giving them an overwhelming advantage after sunset. A lone Neanderthal or early Homo sapiens caught in the open after dark, exhausted from a day's hunting and weighed down with meat, would have been ideal prey, slow, distracted, and unable to effectively fight back against multiple attackers striking from different angles. The relationship between humans and cave hyenas shaped both species in profound ways. Fire became not just a source of warmth and cooking, but a defensive barrier that hyenas instinctively avoided. Neanderthal sites consistently show elaborate hearths positioned near cave entrances, not for cooking efficiency, but for security, creating a wall of flame between sleeping humans and the predators lurking in the darkness beyond. Weapon development accelerated partly in response to hyena threats. Spears effective against large herbivores were equally necessary for defending against pack predators that hunted cooperatively. Social bonds within human groups strengthened because individuals who maintained group cohesion survived, while those who wandered alone or fell behind became hyena prey. Competition for resources intensified the conflict. Both humans and hyenas were persistence hunters targeting the same prey species: horses, bison, reindeer, and young megafauna. Both required similar territories with access to water, prey concentrations, and suitable denning sites. The fossil record shows evidence of violent encounters where this competition turned lethal. Neanderthal skeletons occasionally show trauma patterns consistent with hyena attacks: crushed limbs, puncture wounds from massive canines, and patterns of bone damage that suggest defensive injuries sustained while fighting off attackers. Conversely, cave hyena remains sometimes show injuries from human weapons, spear impacts, fractured skulls from club blows, and evidence of deliberate killings near den sites, suggesting humans actively eliminated hyena packs that posed threats to their groups. The decline of cave hyenas began as the last ice age waned and climatic warming transformed European ecosystems. Megafauna populations collapsed, eliminating much of the prey base that supported large predator populations. At the same time, human populations were growing more sophisticated in their hunting technologies and territorial defense strategies. The combination of reduced prey availability and increased pressure from an increasingly dominant human presence pushed cave hyenas toward extinction. By 10,000 years ago, they had disappeared from Europe entirely, outlasted by modern humans who had learned every lesson the hyenas taught about cooperation, territorial defense, and the strategic use of landscape features for survival. The evolutionary arms race had ended with humans victorious, not because we were stronger or faster, but because we learned faster and adapted more flexibly than the predators that once hunted us in the darkness beyond the firelight. Megalania, the giant lizard of Australia. When the first humans arrived in Australia roughly 65,000 years ago, they stepped onto a continent dominated by megafauna unlike anything their ancestors had encountered in Africa or Eurasia. Among these giants moved a predator so large and dangerous that it has left permanent marks on Aboriginal oral traditions. Megalania prisca, a monitor lizard reaching 7 meters in length and weighing up to 600 kilograms, making it the largest terrestrial lizard in Earth's history. This was not a dinosaur surviving in isolation. It was a relatively recent evolutionary development, a monitor lizard lineage that had been scaling up in size for millions of years in response to Australia's unique prey assemblages. For early Aboriginal peoples, Megalania represented a predatory threat categorically different from anything mammalian. A cold-blooded ambush hunter with toxic saliva, crushing jaws, and the patience to wait motionless for hours before delivering a single, crippling attack. The biology of Megalania remains partially reconstructed from incomplete fossil material, but what exists paints a picture of a supremely adapted ambush predator. Its skull was built for delivering devastating bites with interlocking teeth designed to hold and tear rather than cleanly slice. The jaw muscles attached to enlarged skull crests, providing bite forces estimated to exceed those of modern saltwater crocodiles, despite Megalania's more gracile build. Its legs were positioned more upright beneath the body compared to most modern lizards, allowing for short bursts of surprising speed, not sustainable running, but explosive charges over 10 to 20 meters that could close the distance on prey before targets could react. The long tail provided balance during these attacks and could potentially have been used as a weapon, sweeping sideways to knock prey off balance. The most terrifying aspect of Megalania may have been its saliva. Modern monitor lizards, including Komodo dragons, possess oral secretions containing anticoagulants, shock-inducing compounds, and bacteria that cause rapid infection in wounded prey. While direct evidence of Megalania's saliva chemistry doesn't survive fossilization, its close relationship to monitors that possess these traits makes it overwhelmingly likely that Megalania employed similar biological weaponry. A bite from Megalania wouldn't need to be immediately fatal. Even a glancing wound that broke skin would introduce compounds that prevented blood clotting and induced hypotension, dropping blood pressure and causing shock. Prey that escaped the initial attack would weaken rapidly from blood loss and infection, becoming progressively easier to track and overwhelm as hours passed. This hunting strategy created a predatory threat unlike any mammalian carnivore. Big cats and canids kill through immediate trauma, suffocation, blood vessel rupture, or catastrophic tissue damage. Death comes quickly within minutes. Megalania kills were potentially prolonged events where the initial attack was just the beginning. A human bitten by Megalania and managing to escape would face declining health over subsequent hours or days, with worsening blood loss, increasing weakness, and systemic infection spreading from the wound. The lizard could simply follow at a sustainable pace, using its highly developed vomeronasal sense, tongue flicking to detect chemical traces in the air, to track the wounded prey until it collapsed. This strategy required minimal energy expenditure from the predator while being psychologically devastating for prey that understood they had been doomed by a single bite. Aboriginal oral traditions across Australia preserve detailed accounts of giant lizards that hunted humans, descriptions that align remarkably well with what paleontology suggests about Megalania behaviour. Stories describe creatures that waited near water sources, that could remain motionless for extended periods before attacking, and that pursued wounded prey relentlessly over long distances. Some traditions include specific defensive strategies, making noise to alert others, avoiding dense vegetation where ambushes were likely, and immediately treating bite wounds with cauterization to kill bacteria and seal blood vessels. These weren't abstract myths. They were practical survival information passed down through generations that had lived alongside Megalania and paid the cost of learning its hunting patterns. The environmental context made encounters inevitable. Megalania inhabited the same woodlands, grasslands, and riparian corridors that early Aboriginal peoples relied on for food, water, and travel routes. The lizard's ambush strategy meant it congregated near predictable animal pathways, game trails to water sources, river crossings, and natural bottlenecks in terrain where prey movement was constrained. These were precisely the locations humans also frequented, creating overlap that forced regular confrontations. Unlike mammalian predators that were active primarily at specific times, Megalania, as a reptile, could hunt whenever temperatures were suitable, expanding the window of danger beyond dawn and dusk into midday hours when humans assumed safety. Size distribution in Megalania populations meant threats came in multiple forms. Juveniles 1 to 2 meters long could climb trees and might have preyed on children or targeted humans in arboreal refuges. Mid-sized individuals 3 to 4 meters long were agile enough for active hunting, while large enough to tackle adult humans. The true giants, 6 to 7 meters long, were probably more sedentary, relying almost entirely on ambush and scavenging, but represented lethal threats at close range due to their massive bite force and reach. This size diversity meant humans couldn't develop a single defensive strategy. They had to remain vigilant against multiple threat profiles simultaneously. The extinction of Megalania occurred relatively soon after human arrival in Australia, probably within 20,000 years. The timing suggests human involvement, though the mechanisms remain debated. Direct hunting would have been dangerous but possible. Coordinated attacks with fire and spears could overwhelm even large individuals. More likely, humans contributed to Megalania extinction indirectly by hunting the megafauna prey base that sustained the giant lizards and by using fire to modify habitats, reducing the dense vegetation cover that ambush predators required. As prey became scarce and hunting habitat degraded, Megalania populations fragmented and declined. By 40,000 years ago, they were gone entirely, leaving behind only bones, Aboriginal traditions, and the genetic legacy in modern Australian monitors that still carry some of the largest lizard species alive today. Distant echoes of a time when reptiles, not mammals, ruled the continent's apex predator niches. Thylacoleo, the marsupial lion. In Australia's Pleistocene ecosystems, where evolution had spent millions of years in isolation producing mammals radically different from those on other continents, one creature stood as the continent's supreme mammalian predator, Thylacoleo carnifex, the marsupial lion. Despite its name, Thylacoleo wasn't a lion or even closely related to felines. It was a marsupial that had convergently evolved predatory features so effectively it became one of the most efficient killers in mammalian history. Weighing up to 160 kilograms and built with the most powerful bite force relative to body size of any mammal ever measured, Thylacoleo represents evolution's alternative experiment in apex predation. A pouched carnivore that climbed trees, ambushed from above, and delivered killing bites with teeth unlike those of any other predator before or since. For the first humans arriving in Australia, Thylacoleo was a nightmare creature that hunted in ways no African or Eurasian predator had prepared them for. The skull and dentition of Thylacoleo reveal a killer adapted for precision execution. Its canine teeth were reduced and relatively small, but its incisors were massive, long, blade-like structures that protruded forward like shearing implements. The real killing tools were the premolars, specifically modified into carnassials far larger relative to body size than those of any modern carnivore. These teeth acted like biological bolt cutters, capable of shearing through hide, muscle, and bone with mechanical efficiency that exceeded modern big cats. Biomechanical analysis shows Thylacoleo could generate bite forces of approximately 2,000 newtons, comparable to a much larger African lion, but delivered through a smaller skull with surgical precision. The jaw muscles attached to greatly enlarged skull crests, and the mandible was reinforced to withstand the immense stresses generated during biting. The killing strategy this dental arrangement enabled was brutally effective. Thylacoleo didn't rely on suffocating throat bites like big cats or prolonged bleeding like canids. Instead, it delivered catastrophic trauma through precise shearing bites to the skull, neck, or spine. Fossil evidence from prey species shows bite marks consistent with Thylacoleo attacking from above or behind, targeting the base of the skull, where a single powerful bite could sever the spinal cord or crush critical brain structures. Death was almost instantaneous. No prolonged struggle, no chase across open ground, just a sudden drop from a tree branch, followed by a precise, lethal bite that ended the hunt in seconds. This hunting method required extraordinary adaptations for climbing and ambush positioning. Thylacoleo possessed semi-retractable claws, a feature seen in few other mammals and particularly rare in carnivores, that provided excellent grip on tree bark and rocky surfaces. Its limb proportions were unusual for a large predator, with relatively short but immensely powerful legs that prioritized strength over speed. The tail was thick and muscular, possibly acting as a brace during climbs or as a balance mechanism during leaping attacks. Fossil evidence from cave deposits shows Thylacoleo remains in elevated positions, suggesting individuals regularly occupied den sites in rock shelters accessible only through climbing, behavior unprecedented in large mammalian predators. The implications for early human populations were profound and terrifying. African and Eurasian predators hunted from ground level or in open water. Humans had evolved countless defensive strategies against terrestrial threats. Thylacoleo attacked from above, using tree cover and elevated positions to ambush prey that felt safe under canopy. This fundamentally changed the risk calculation for early Aboriginal peoples. Dense forest wasn't safer than open ground. It was potentially more dangerous because every overhead branch could conceal a waiting predator. Walking beneath trees required constant upward vigilance, a cognitive burden that no African savanna experience had prepared them for. Aboriginal oral traditions contain accounts of large, predatory animals that hunted from trees, creatures described as dropping onto prey from above and capable of climbing with agility despite significant size. Include specific warnings about certain tree types or forest zones where these predators concentrated. Rock art from various regions depicts large, powerfully built animals with forward-facing eyes and prominent claws, images that align well with Thylacoleo reconstructions. These weren't mythological monsters, but practical knowledge systems preserving information about a real predatory threat that required specific defensive behaviors, avoiding certain habitats, making noise while moving through forests, and maintaining group cohesion even under canopy where visibility was limited. The ecological relationship between Thylacoleo and Australian megafauna shaped its hunting strategies in ways that directly impacted humans. Its primary prey included giant wombats, large kangaroos, and juvenile megafauna, animals that were powerful, potentially dangerous, and difficult to kill without specialized adaptations. Thylacoleo's ambush from above strategy minimized risk by targeting the prey's most vulnerable area, the head and neck, while attacking from a position where the prey's defensive capabilities, kicking, biting, ramming, were least effective. This same strategy worked equally well on humans who lacked the protective armor or weaponry to defend against overhead attacks delivered with enough force to shatter bone. Size estimates for Thylacoleo vary based on which fossil specimens are used for reconstruction, but the largest individuals approach the size of modern female lions, while being built far more robustly. The forelimbs were particularly powerful, with attachment sites for muscles that would have provided immense gripping strength. When Thylacoleo landed on prey from above, it didn't just deliver a bite, it wrapped those powerful forelimbs around the victim, using semi-retractable claws to secure hold, while the killing bite was administered. Escaping from this attack would have been virtually impossible. The combination of impact force, gripping strength, and immediate lethal trauma gave prey almost no survival window. The extinction of Thylacoleo followed within approximately 20,000 years after human arrival, timing that strongly suggests human involvement, though precise mechanisms remain uncertain. Direct hunting would have been exceptionally dangerous. Attacking an animal that could drop from above and deliver instant kill bites required either projectile weapons or coordinated group tactics with fire. More likely, humans contributed to extinction through habitat modification and prey-based reduction. Thylacoleo depended on specific ecosystem structures, forested areas with suitable climbing trees near prey concentration zones. Aboriginal fire management practices, which transformed large areas from forest to grassland, would have fragmented Thylacoleo habitat. Simultaneously, human hunting pressure on megafauna eliminated key prey species, forcing Thylacoleo to target progressively smaller, less efficient prey items. The combination of habitat loss and food scarcity proved insurmountable for a specialized predator that couldn't adapt quickly enough to human-driven ecosystem transformation. Short-faced bears, giants of Ice Age America. When Pleistocene humans crossed the Bering Land Bridge into North America, they encountered a predatory landscape dominated by creatures whose very existence challenged belief. And among these giants, none was more formidable than Arctodus simus, the short-faced bear. This wasn't just a large bear, it was the largest mammalian land predator in North American history, standing 2 meters tall at the shoulder, when on all fours and exceeding 3.5 meters when reared upright. With a skull built for crushing force and limbs designed for sustained high-speed pursuit, the short-faced bear represented an evolutionary peak in terrestrial predation. A bear that had abandoned the omnivorous flexibility of its relatives and specialized into a pure hypercarnivore, adapted for running down prey across open Pleistocene grasslands. For early Paleo-Indian populations, Arctodus was an existential threat that shaped settlement patterns, hunting strategies, and the very possibility of human colonization across large regions of Ice Age America. The anatomy of Arctodus reveals a predator optimized for a hunting strategy unique among bears. Its limbs were proportionally longer than those of any modern bear species, with reduced muscle mass in the lower legs but tremendously powerful hip and shoulder musculature. Exactly the build seen in pursuit of predators like wolves and African wild dogs. Biomechanical analysis suggests Arctodus could sustain running speeds of 40 to 50 kilometers per hour over considerable distances, making it faster than any human and capable of running down horses, bison calves, and early camels that populated Pleistocene America. This was revolutionary for ursides. While modern bears can charge explosively over short distances, none can sustain speed over the kilometers necessary for true pursuit hunting. Arctodus could, giving it access to prey strategies that other bears never developed. The skull structure reinforced this carnivorous specialization. The face was indeed shortened compared to other bears, hence the name. But this wasn't merely aesthetic. The shorter muzzle provided greater mechanical advantage for the jaw muscles, generating higher bite forces through reduced leverage distances. The teeth showed clear carnivore adaptations, reduced molars compared to omnivorous bears, enlarged carnassials for shearing meat, and robust canines designed for piercing and holding, rather than the multi-purpose teeth of omnivores. Stable isotope analysis of Arctodus bones confirms that different populations showed varying degrees of carnivory, with some approaching dietary patterns seen in pure carnivores like lions. These weren't bears that supplemented meat with berries and roots. These were active predators that pursued, killed, and consumed large prey as their primary food source. The ecological implications of an active pursuit predator weighing up to 800 kilograms were staggering. Arctodus didn't need to ambush or wait for weakened prey. It could run down healthy adults across open terrain, sustaining pursuit until prey was exhausted. This fundamentally changed predator-prey dynamics in Pleistocene America. Herbivores that had evolved defensive strategies against ambush predators like saber-toothed cats suddenly faced a predator that could follow them for kilometers without tiring. The psychological impact alone would have been devastating. No terrain offered safety through distance or endurance, only through reaching physical barriers that massive bears couldn't navigate. For humans, Arctodus presented challenges that had no parallel in their evolutionary experience. African and Eurasian predators, even large ones like lions and cave bears, were fundamentally ambush hunters or opportunistic scavengers that humans could avoid through vigilance and habitat selection. Arctodus could pursue humans across open ground, track them over long distances, and potentially follow groups for days waiting for stragglers to fall behind. The bear's size meant it could tear through shelters that would deter smaller predators, and its intelligence, comparable to modern bears, meant it could learn individual human behaviours and adapt strategies accordingly. Reports from later periods when grizzlies still extensively hunted humans describe bears that would shadow human parties for days, waiting for opportunities, learning camp routines, and striking when defences were lowest. Arctodus likely employed identical tactics, but with even greater efficiency due to its larger size and more carnivorous lifestyle. Fossil evidence provides glimpses of Arctodus behaviour that hint at its predatory capabilities. Den sites show accumulations of large mammal bones, some clearly processed by carnivores, suggesting Arctodus cached kills and returned to feed over multiple days. Behaviour seen in modern large carnivores, but unusual for bears. The geographic distribution shows Arctodus concentrated in open grasslands and parklands, precisely the habitats where pursuit hunting would be most effective, and where human populations also focus their activities for hunting large game. This overlap wasn't coincidental. Both species were targeting the same prey assemblages and using similar landscape features for strategic advantage. The relationship between humans and Arctodus may have included direct predation, particularly on children, elderly, or injured individuals who couldn't maintain pace with travelling groups. Paleo-Indian sites occasionally showed defensive structures, barriers made from mammoth bones, strategic use of fire, and camp locations in areas with protected approaches, suggesting early Americans were deeply concerned with defense against large predators. The cultural emphasis on group cohesion, the development of long-distance projectile weapons, and the rapid spread of humans into diverse environments rather than concentrating in optimal habitats all point to populations trying to minimize exposure to specific high-risk zones where predators like Arctodus dominated. Competition for resources intensified the conflict. Both humans and Arctodus were apex predators targeting megafauna, young mammoths, horses, bison, and camels. Both required enormous caloric intake to sustain themselves, meaning they needed access to concentrated prey populations. Archaeological kill sites sometimes show evidence of carnivore scavenging, with large teeth marks on butchered bones indicating that bears arrived at human kills to steal meat. Whether these were Arctodus or other bear species remains uncertain, but the pattern suggests direct competition where successful human hunts attracted predators powerful enough to displace human groups from their kills. The extinction of Arctodus approximately 11,000 years ago remains partially mysterious. Climate change eliminated much of the open grassland habitat that Arctodus depended on for pursuit hunting, fragmenting populations and reducing prey density. Simultaneously, megafauna were declining, whether from climate change, human hunting, or both, eliminating the large prey base that sustained such massive carnivores. Humans may have also contributed through direct killing, either defensively or to eliminate dangerous competitors. A predator as specialized as Arctodus couldn't adapt quickly enough when all three pressures hit simultaneously: habitat loss, prey decline, and pressure from an increasingly dominant human presence. By the start of the Holocene, the short-faced bear was gone entirely, leaving behind only fossils and perhaps cultural memories preserved in indigenous traditions that speak of giant bears that hunted humans before the world changed and the megafauna disappeared. Cave lions, Europe's Ice Age apex predator. Across the frozen steppes and tundra forests of Ice Age Europe and Asia, a predator moved that represented the culmination of feline evolution, Panthera spelaea. the cave lion. This wasn't simply a large version of modern lions. It was a distinct species that had adapted to extreme cold climates, evolved social structures suited for hunting megafauna, and grown to sizes that made it among the largest cats ever to walk the earth. Males could exceed 300 kilograms, roughly 50% larger than modern male African lions, with massive heads, powerful builds, and adaptations for taking down prey ranging from reindeer to young, woolly mammoths. For Neanderthals and early Homo sapiens populations competing for resources in Pleistocene Eurasia, cave lions represented a constant deadly threat. Apex predators that occupied the same caves humans needed for shelter, hunted the same game humans depended on, and occasionally turned their considerable killing abilities toward hunting humans themselves. The evolutionary relationship between cave lions and humans stretched back hundreds of thousands of years, creating a predator-prey dynamic that fundamentally shaped human behavior and survival strategies. Unlike other predators that only periodically encountered humans, cave lions shared nearly identical habitat requirements. They needed rock shelters for protection from weather and for raising cubs. They hunted across open tundra steppe environments where large herbivores concentrated, and they required territories with reliable water and prey access. This overlap meant regular, sustained contact, where both species competed for limited resources in harsh Ice Age environments where margins of survival were desperately thin. The physical capabilities of cave lions set them apart from any feline predator humans face today. Reconstructions based on complete skeletons show animals with massive barrel chests, enormously powerful forelimbs, and skulls built to deliver suffocating bites to large prey. The canine teeth were longer and more robust than those of modern lions, suggesting they regularly tackled dangerous prey that fought back. Animals like steppe bison, horses, and young megafauna that could inflict serious injuries if the kill wasn't executed perfectly. The jaw muscles attached to greatly expanded skull crests, providing bite forces that could crush windpipes and cervical vertebrae even through thick fur and hide. These weren't cats that killed through blood loss. They killed through asphyxiation and spinal trauma, methods that worked just as effectively on humans as on any other prey. Cave lions' social structure remains partially speculative, but evidence suggests they lived in groups. Cave deposits show multiple individuals of different ages sharing den sites, and isotope analysis indicates related females remained together while males dispersed. This pride structure would have made them even more dangerous to early humans. A lone lion is formidable. A coordinated group is nearly unstoppable. Modern lions hunt cooperatively, with different individuals playing specific roles. Flankers drive prey toward ambush points. Attackers deliver killing blows, and the group shares the kill. Cave lions likely employed similar tactics, but refined for Ice Age prey species that were larger, more aggressive, and more dangerous than African herbivores. These same tactics would transfer seamlessly to hunting humans, particularly small groups caught in open terrain or isolated individuals separated from their bands. The fossil and archaeological records preserve numerous hints of cave lion-human interactions. Neanderthal sites across Europe show defensive modifications. Hearths positioned strategically near cave entrances, barriers constructed from bones and stones, and evidence of regular occupation shifts suggesting groups abandoned sites when predator pressure became too intense. Some Neanderthal remains show trauma patterns consistent with large carnivore attacks, including puncture wounds from massive canines and patterns of bone damage suggesting bodies were at least partly consumed by predators. Whether these individuals were killed by lions or scavenged after death remains debated, but the evidence confirms that Neanderthals ended up as food for cave predators on multiple occasions. More compelling are the deliberate killings of cave lions by humans. Several sites preserve cave lion remains, showing clear signs of human modification. Cut marks from stone tools, evidence of skinning, and burial context suggesting the pelts held cultural significance. The famous Chauvet Cave in France contains extraordinary Paleolithic art depicting cave lions with remarkable anatomical accuracy, including details of posture, mane structure, and behavioral traits that could only come from sustained, close observation. This wasn't abstract art. It was detailed documentation of a predator that occupied central importance in human consciousness. The art shows lions hunting in groups, lions stalking prey, and lions interacting with other Ice Age megafauna, a record of predatory behavior created by humans who lived alongside these animals and needed to understand their patterns to survive. The psychological impact of cave lions extended far beyond direct predation risk. Their roars, similar to modern lions but likely deeper and more powerful, given their larger size, would have carried for kilometers across open tundra. This acoustic territoriality meant humans could hear lions even when they couldn't see them, creating constant awareness of predatory presence. The scent-marking behavior typical of big cats would have left olfactory warnings across human territories, daily reminders that apex predators were monitoring the same landscapes. This chronic low-level stress would have influenced countless small decisions: where to camp, when to travel, whether to remain at a kill site or abandon meat to avoid attracting predators, how large a group needed to be before venturing into certain areas. Competition for calves intensified the relationship. Suitable rock shelters were limited resources in Ice Age Europe, and both species absolutely required them. Humans for protection from weather and as bases for tool manufacture and food processing. Lions for raising cubs and escaping temperature extremes. The archaeological record shows repeated patterns where caves change hands between human and carnivore occupation, sometimes rapidly, suggesting ongoing contests for prime locations. Some caves show evidence of violent confrontations, burned areas suggesting humans used fire to drive out lions, scattered human and lion remains suggesting fights occurred, and modifications to cave entrances suggesting both species constructed barriers to control access. The decline of cave lions began as the last Ice Age ended and continued through the early Holocene. Climate change eliminated the open tundra steppe environments that supported massive herbivore populations, fragmenting lion territories and reducing prey density. Simultaneously, human populations were growing more sophisticated in hunting technologies and territorial defense. The combination proved unsustainable for a large predator requiring enormous territories and abundant prey. By 14,000 years ago, cave lions had disappeared from most of Europe. They persisted longer in parts of Asia, but were gone entirely by 12,000 years ago, outlasted by humans who had learned every lesson those deadly cats taught about territorial defense, cooperative hunting, and the strategic control of landscape features. The caves were finally ours, not because we defeated cave lions in direct combat, but because we adapted faster than they could to the rapidly changing world of the terminal Pleistocene. Crocodylus thorbjarnarssoni, the giant crocodile of ancient Africa. In the waterways of Pleo-Pleistocene Africa, where early hominins descended from trees and began exploring terrestrial lifestyles, death lurked beneath every river surface in the form of Crocodylus thorbjarnarssoni, a crocodile so massive it makes modern Nile crocodiles look like juveniles. This ancient species reached lengths exceeding 7.5 meters and weights approaching 1,000 kilograms, making it one of the largest crocodilians of the past 5 million years. For Australopithecus and early Homo populations whose evolution depended on accessing riparian resources, this giant crocodile represented an ever-present mortal threat. Every drink of water, every river crossing, every attempt to fish or gather aquatic plants meant risking an attack from a predator capable of seizing an adult hominin, dragging them underwater and drowning them before their companions could react. The relationship between early humans and these massive reptiles shaped fundamental behaviors around water access that persist in modern human psychology millions of years after the crocodile's extinction. The fossil record of Crocodylus thorbjarnarssoni comes primarily from sites in East Africa's Turkana Basin, exactly the regions where critical hominin evolution occurred. This geographic overlap wasn't coincidental. Both hominins and giant crocodiles concentrated in areas with permanent water, productive riparian zones, and abundant prey. The crocodile's remains appear in the same geological layers as Australopithecus and Homo habilis fossils, creating a clear timeline. For at least 2 million years, our ancestors lived under constant threat from aquatic predators far larger and more powerful than any crocodile populations humans face today. This sustained predatory pressure throughout the period when our ancestors were developing bipedalism, larger brains, tool use, and early culture means the crocodile threat was woven into the very fabric of hominin evolution. The hunting strategy of Crocodylus thorbjarnarsoni followed the ambush template perfected by crocodilians but scaled to intimidating proportions. These reptiles could remain motionless at the water's edge or just beneath the surface for hours, conserving energy while monitoring shoreline activity. When suitable prey approached, whether hominin, antelope, or early horse, the attack came with explosive violence. Crocodilians can launch themselves partially out of the water, covering several meters of shoreline in under a second, using their massive tails for propulsion. For a crocodile this size, the strike zone extended far beyond what smaller species could achieve. Hominins, who thought they were safely distant from the water's edge, could find themselves seized in jaws capable of generating bite forces exceeding 20,000 newtons. Once seized, escape was virtually impossible. The jaws clamped down with enough force to crush bone, and the crocodile immediately executed the signature death roll, rotating rapidly on its long axis to disorient prey, break limbs, and begin the drowning process. For hominins, who lacked the thick hides and massive body mass of animals like buffalo, the death roll would have been instantly devastating. Limbs would detach, the spine would fracture, and consciousness would be lost within seconds as the brain was starved of oxygen and blood. Drowning followed quickly, and once the prey stopped struggling, the crocodile would wedge the body beneath submerged logs or in underwater caves to decompose. Crocodilians prefer slightly aged meat and often wait days before consuming kills. The fossil evidence provides glimpses of these predatory interactions. Hominin fossils from Turkana show tooth marks consistent with large crocodilian predation. Some bones show clear puncture wounds from massive conical teeth. Others show the scraping damage from teeth being dragged along bone surfaces as the crocodile processed remains. Particularly telling are juvenile hominin fossils that appear in crocodile-associated deposits. Young individuals would have been priority targets, easier to grab and less capable of fighting back. The presence of hominin remains in the same deposits as Crocodylus thorbjarnarsoni isn't proof of predation, but the pattern is suggestive. Hominins were dying near water, and giant crocodiles were the primary large predators in those environments. The ecological relationship between hominins and crocodiles created an evolutionary pressure cooker around water access. Early hominins couldn't avoid water. They needed it for drinking, for accessing aquatic foods, and for temperature regulation in the hot African climate. But every water interaction carried risk. This pressure likely drove multiple behavioral innovations. Group vigilance became essential. Individuals at the water's edge needed sentries watching for surface disturbances that indicated crocodile presence. Approach patterns became strategic, coming to water at locations with good visibility, avoiding dense vegetation where crocodiles could conceal themselves, and never becoming predictable in timing or location. Tool use may have been partly driven by the need to access water safely. Long poles could test depth and probe for hidden crocodiles before individuals committed to approach. Fire adoption provided partial protection. Crocodiles instinctively avoid fire, and maintaining fires near regular water access points would have created safe zones. The archaeological record shows Haast's position strategically near ancient lake shores and river margins, possibly serving as much for predator deterrence as for warmth or cooking. Social learning became critical. Individuals needed to learn from their elders which water sources were safer, what times of day carried less risk, and how to read environmental cues that indicated crocodile activity. Those who learned survived. Those who didn't became crocodile meals, creating strong selection for cultural transmission of survival knowledge. The relationship also influenced settlement patterns. Hominin sites from this period often show strategic positioning, elevated areas with visibility to water rather than directly on shorelines, locations near water but with escape routes to elevated terrain, or sites where water could be accessed through narrow approaches that could be defended or monitored. This wasn't paranoia. It was practical adaptation to living in a landscape where some of the deadliest predators were invisible until they attacked. Crocodylus thorbjarnarsoni eventually went extinct, likely unable to compete with changing ecosystems and the more adaptable Nile crocodile that replaced it. But the behavioural legacy remained. Modern humans across cultures show deep-seated wariness around water inhabited by crocodilians, despite lacking personal predation experience. Children who have never seen a crocodile instinctively understand that still water poses danger, that water edges require vigilance, and that approaching water requires caution. These aren't learned behaviours. They're psychological predispositions shaped by millions of years of ancestors who survived because they feared what lay beneath the surface. The giant crocodile is extinct, but the fear it created remains hardwired into human consciousness, an evolutionary gift from predators that taught our species to respect the water and approach it with the wariness necessary to see another dawn. Pachycrocuta brevirostris, the giant hyena of Asia. In the Pleistocene landscapes of Asia and Europe, where early Homo populations dispersed out of Africa and encountered ecosystems filled with unfamiliar predators, one carnivore stood as perhaps the most dangerous terrestrial threat they faced: Pachycrocuta brevirostris, the giant short-faced hyena. This wasn't a species closely related to modern spotted hyenas. It was a separate, massively built lineage that had evolved to fill specialized predator niches in Eurasian ecosystems. Adults exceeded 150 kilograms, substantially larger than any extant hyena species, with skulls built for bone-crushing power that approached that of extinct saber-toothed cats. For early Homo erectus populations expanding across Asia, Pachycrocuta represented a terrifying combination of size, strength, intelligence, and pack coordination that made it the dominant predator in many regions and a direct competitor and occasional hunter of early humans. The anatomy of Pachycrocuta reveals a predator adapted for direct confrontation with large, dangerous prey and for accessing nutritional resources other carnivores couldn't exploit. The skull was shortened compared to modern hyenas, hence the brevirostris designation, meaning short-faced, but massively reinforced with enlarged muscle attachment crests and thickened bone structure throughout. The premolars and molars were particularly robust, designed not just for slicing meat, but for cracking open the largest bones of megafauna prey. Bite force estimates place Pachycrocuta among the most powerful mammalian carnivores, capable of generating forces sufficient to shatter elephant-long bones and crush rhinoceros skull plates. This gave the species access to bone marrow and brain tissue that remained locked away after other predators had finished with kills. This scavenging capability had profound implications for human competition. Early Homo populations relied heavily on scavenging, approaching predator kills after the original hunters had eaten their fill, then using stone tools to extract remaining meat and marrow. Pachycrocuta hyenas could eliminate this food source entirely by consuming everything, including bones that humans needed stone tools to access. Archaeological sites from Asia show clear evidence of carnivore competition, cut marks from stone tools overlain by carnivore tooth marks, indicating humans processed carcasses first, and carnivore tooth marks overlain by cut marks, showing humans scavenged after carnivores fed. Chemical analysis of modified bones sometimes reveals hyena gnawing patterns consistent with Pachycrocuta, rather than smaller species, suggesting direct competition between giant hyenas and humans for the same resources. But Pachycrocuta wasn't merely a scavenger. Evidence from den sites shows this species actively hunted, targeting prey ranging from horses and ancient cattle to juvenile megafauna. The short face and powerful build suggest a hunting style different from pursuit-adapted cursorial predators. Pachycrocuta likely relied on ambush, combined with overwhelming power and bite force, attacking prey at close range, then using immense jaw strength to deliver crippling bites to limbs or spine. Once prey was immobilized, the pack could converge to finish the kill. This strategy would work equally well on humans, especially isolated individuals or small groups caught away from defensive positions. The pack structure of Pachycrocuta remains partially speculative, but den sites containing multiple individuals of various ages suggest social living similar to modern hyenas. If Pachycrocuta clans operated with the same female-dominated hierarchies, cooperative hunting, and territorial defense seen in modern species, they would have been formidable opponents for early humans. A coordinated pack of giant hyenas could defend kills against any other predator, could raid human camps to steal food, and could potentially hunt humans directly if opportunity and hunger align. Modern spotted hyenas occasionally prey on humans in regions where the species overlaps with vulnerable populations. Pachycrocuta, being substantially larger and more powerful, would have posed an even greater direct threat. Fossil evidence preserves glimpses of these interactions. Hominin fossils from sites in China show damage patterns consistent with large carnivore scavenging or predation. Some bones display tooth marks from massive carnivores that could be Pachycrocuta. Others show evidence of being transported and processed in ways consistent with hyena catching behavior. The famous Zhoukoudian cave system in China, which preserves extensive Homo erectus remains, also shows evidence of large hyena occupation, creating ongoing debate about whether humans controlled the cave and were occasionally killed by hyenas, or whether hyenas controlled the cave and humans were regular prey items brought in by the predators. The competition extended beyond direct predation to territorial control and psychological warfare. Hyenas are notoriously difficult neighbors, intelligent, persistent and fearless when operating in groups. They steal food, harass competitors, test defenses constantly, and remember individual humans or animals that present threats or opportunities. A Pachycrocuta clan sharing territory with a Homo erectus band would create constant tension. Every hunt would risk hyena theft. Every camp would require defense. Every nightfall would bring vocalizations. The whooping, giggling and moaning calls of hyenas communicating across territories, reminding humans that predators were watching, waiting and probing for weakness. The extinction of Pachycrocuta, roughly 500,000 years ago, remains incompletely understood, but the timing coincides with increasing hominin sophistication and the arrival of more specialized, efficient Eurasian predators. As humans improved hunting technologies, expanded social networks, and developed better defensive strategies, they likely reduced the scavenging opportunities that partly sustained Pachycrocuta. Simultaneously, more cursorial predators, like wolves, and more generalized carnivores like cave hyenas were diversifying and adapting to changing Pleistocene climates. Pachycrocuta, specialized for bone-crushing and power-based hunting, may have been outcompeted on multiple fronts, by humans controlling carcass access, by faster predators taking prey first, and by climate changes that altered prey availability. The giant short-faced hyena vanished, but its ecological role in shaping early human behavior persisted. We remain intensely protective of food resources, maintain constant vigilance around campsites, and use fire partly because our ancestors learned that flames kept the night hyenas at bay. Terror birds, South America's apex predators. When humans first entered South America approximately 15,000 years ago, they stepped onto a continent where the rules of predation had been written by birds, not mammals. For 60 million years, South America had been isolated from other landmasses, allowing evolution to produce ecosystems where the apex predators weren't cats or wolves, but massive, flightless birds known as forest racids, the terror birds. By the time humans arrived, most terror bird lineages had already vanished, outcompeted by mammalian carnivores that entered from North America. But some species persisted into the terminal Pleistocene, and the psychological impact of living alongside predatory birds standing 2 meters tall, armed with axe-like beaks capable of killing with a single strike, would have shaped early South American human cultures in ways still detectable in indigenous traditions and settlement patterns. The anatomy of terror birds represented nature's experiment in creating avian apex predators, and the results were nightmare creatures built for devastating close-quarters combat. The skull was massive relative to body size, housing a beak that functioned more like a pickaxe than a typical bird structure. Unlike predatory birds that grab with talons and tear with beaks, terror birds use their beaks as primary killing weapons, swinging their heads downward to drive the hook tip through prey skulls or into vital organs. Biomechanical analysis shows the neck musculature could generate enormous downward striking force, while the skull bones were reinforced to absorb impact shock without fracturing. This strategy allowed terror birds to dispatch prey quickly through catastrophic head trauma, a killing method no modern bird employs. The legs revealed a predator built for speed and lethal kicks. Terror birds had proportionally longer legs than any extant flightless bird, with modifications suggesting they could sustain running speeds approaching 50 kilometers per hour over moderate distances. The feet carried massive claws on each toe, particularly an enlarged sickle claw similar to those seen in dromaeosaur dinosaurs. These claws served multiple functions: gripping terrain during high-speed pursuit, pinning prey during attacks, and potentially delivering disemboweling kicks if threatened or cornered. A kick from a full-grown terror bird would have carried enough force to shatter human ribs or rupture vital organs, turning defensive maneuvers into lethal attacks. The ecological context in which humans encountered surviving terror birds created inevitable conflict. Both species occupied similar niches as cursorial hunters targeting medium to large prey in grassland and open woodland environments. Both required access to concentrated prey populations and competed for the same resources. Archaeological evidence from early South American sites shows human hunting focused heavily on ground sloths, horses, and camelids, precisely the prey items that sustained terror bird populations. This resource overlap forced direct competition where humans and birds would have encountered each other regularly at kill sites, water sources, and prey concentration zones. Direct predation of humans by terror birds remains speculative but plausible, particularly targeting children or disabled individuals who couldn't flee effectively. A human child would fall well within the size range of typical terror bird prey. The bird's hunting strategy, pursuit followed by devastating beak strikes to the head, would have been instantly fatal to vulnerable humans, and the strike itself would happen far faster than defensive reactions. Modern cassowaries, while much smaller than terror birds, occasionally kill humans through similar tactics, closing distance rapidly, then delivering lethal kicks or using their casque as a battering weapon. Terror birds employed analogous strategies, but at 3 times the size, with proportionally more powerful weaponry. Indigenous oral traditions across South America preserve accounts of giant predatory birds, descriptions that align remarkably well with terror bird morphology and behavior. Some traditions describe birds that hunted in pairs or small groups, matching evidence that some forest racids may have had cooperative hunting behaviors. Others detail specific defensive strategies, making loud noises, using fire, or climbing into terrain where the large birds couldn't follow. These weren't abstract myths, but practical survival information suggesting sustained human-terror bird interactions continued for some period after humans arrived. The psychological impact of facing avian predators would have been disorienting for populations whose African and Eurasian ancestors had spent millions of years adapting to mammalian threats. Mammalian predators telegraph attacks through stalking behavior, scent marking, and vocalizations that primates instinctively recognize. Birds operate differently. Their visual processing and movement patterns follow different rules, and their vocalizations lack the acoustic structure that mammalian predators use. Terror birds would have been cognitively alien threats, difficult to predict or understand using behavioral templates developed for dealing with cats, bears, or wolves. This uncertainty may have made them psychologically more disturbing than mammalian predators of equivalent danger. Competition rather than direct predation likely drove most human terror bird conflict. Early human hunters used simple spear technology and group coordination to take down large prey. They needed time to process carcasses before meat spoiled or attracted other predators. Terror birds could arrive at kill sites, disperse human groups through intimidation or violence, and claim carcasses for themselves. The reverse scenario, humans scavenging from bird kills, would have been equally fraught. Unlike mammalian carnivores that eat methodically, birds tear flesh rapidly with their beaks, consuming kills quickly and leaving less opportunity for scavenging. Humans arriving at a terror bird kill might find the bird still present, protective of its meal, and perfectly willing to defend it violently. The final extinction of Forus racids occurred shortly after human arrival, with most lineages disappearing by 12,000 years ago. The correlation strongly suggests human involvement, though mechanisms remain debated. Direct hunting would have been extremely dangerous. Approaching a terror bird with only spear technology risked devastating counterattacks. But coordinated group efforts using fire and projectiles could potentially overwhelm individual birds. More likely, humans accelerated extinction indirectly through prey-based reduction. By hunting the medium to large herbivores that sustained terror bird populations, humans removed the food source that made such large carnivorous birds viable. Environmental changes at the Pleistocene-Holocene transition eliminated much of the open habitat terror birds preferred, fragmenting populations and making recovery from human hunting pressure impossible. The birds vanished, leaving behind only fossils, scattered bones, and possibly cultural memories in the traditions of peoples whose ancestors once shared the landscape with the last of evolution's predatory bird experiments. American lions, Pleistocene, North America's largest cat. Across the grasslands, forests, and broken terrain of Ice Age, North America, a predator moved that exceeded every modern big cat in size and killing power, Panthera atrox, the American lion. This enormous feline, reaching weights of 350 kilograms or more, was roughly 25% larger than modern African lions and built with proportionally heavier bones, more massive skulls, and longer limbs, suggesting adaptation for covering vast territories. For Paleo-Indian populations who entered North America during the terminal Pleistocene, the American lion represented perhaps the most formidable mammalian predator they had ever encountered. A cat capable of bringing down adult bison, ancient horses, and even juvenile mammoths, operating alone or in small groups across landscapes where humans were simultaneously trying to establish themselves as the dominant apex predator. The evolutionary history of Panthera atrox remains partially resolved, but genetic evidence suggests it diverged from cave lions hundreds of thousands of years ago after ancestral populations crossed into North America via the Bering Land Bridge. Once isolated, American lions adapted to New World prey assemblages that differed substantially from Eurasian megafauna. North American herbivores, including massive bison, horses, camels, and ground sloths, required predators with extraordinary power to bring them down safely, responded by growing larger, developing even more robust skulls than its cave lion relatives, and possibly evolving more solitary hunting behaviors suited for stalking through the varied terrain of a continent that ranged from Arctic tundra to temperate forests to arid grasslands. Skeletal evidence reveals a predator built for overwhelming power rather than sustained speed. The forelimbs were particularly massive, with enlarged attachment points for muscles that would have provided immense gripping and pulling strength. When an American lion struck prey, it didn't just knock the animal down, it held it down, using body weight and forearm strength to pin struggling victims, while the killing bite was delivered. The canine teeth were longer and stouter than those of modern lions, suggesting they regularly tackled prey with thick neck musculature that required deep penetration to reach vital structures. The jaw muscles attached to greatly expanded skull crests, indicating bite forces that rivaled or exceeded those of contemporary saber-toothed cats, despite having a very different tooth morphology. The killing strategy likely combined ambush and power-based takedowns. Unlike pursuit predators that chase prey to exhaustion, American lions probably stalked to within striking distance using cover, then launched explosive charges over short distances to close final gaps before prey could accelerate to escape speed. Upon contact, the lion would use its massive forelimbs to grapple prey, bowling over animals, hooking legs to trip running targets, or simply bearing them to the ground through superior weight and strength. Once prey was down, the killing bite targeted the throat or nape, with the massive canines driven deep to sever windpipe, blood vessels, or spinal cord. Death came through suffocation, catastrophic blood loss, or instant nervous system shutdown depending on bite placement. For humans, American lions presented threats that operated on multiple levels. Direct predation was certainly possible, particularly on isolated individuals, children, or infirm adults who couldn't fight back or flee effectively. A human falls well within the size range of American lion prey. We're roughly equivalent to juvenile horses or small ground sloths, both documented prey items. The cats were powerful enough to overcome any physical resistance humans could offer without weapons, and fast enough over short distances to catch any human trying to flee. The archaeological record, however, shows limited direct evidence of American lion predation on humans, suggesting such attacks were relatively rare, probably opportunistic events rather than systematic hunting. More significant was competition for resources and territory. American lions and Paleo-Indian hunters targeted many of the same prey species, creating inevitable conflict at kill sites. Lions could easily displace human groups from fresh kills, stealing meat that represented hours or days of human effort. Conversely, lions making kills in territories frequented by humans risked having their food stolen by group-coordinated theft, where multiple humans could drive off even large predators. This competitive dynamic would have been constant and intense, with both species learning to recognize each other as rivals requiring strategic responses rather than simple avoidance. The La Brea tar pits in California provide extraordinary insights into American lion behavior and ecology. Thousands of lion fossils accumulated as individuals became trapped while feeding on mired herbivores, creating a preservation bias that favored predators and scavengers. Analysis of these remains reveals population structures, injury patterns, and dietary information that illuminate how these cats lived. Many individuals show healed injuries, broken bones that mended, damaged teeth that were worn down, and pathology suggesting long-term survival despite serious trauma. This indicates American lions were tough, resilient animals that could recover from injuries that would kill less robust predators, a trait that would make them even more dangerous in conflicts with humans, where wounded animals might continue attacking rather than fleeing. Isotope analysis of American lion bones confirms they were apex predators occupying the highest trophic levels, consuming large herbivores exclusively, with no evidence of omnivory or scavenging small prey. This dietary specialization made them incredibly efficient hunters, but also vulnerable to any disruption of large prey populations. When humans entered North America, they brought sophisticated hunting technologies, refined over thousands of years of pursuing megafauna in other continents. Paleo-Indian hunters rapidly began reducing populations of horses, camels, and other herbivores, removing the prey base that sustained predators, like American lions. The extinction of Panthera atrox approximately 12,000 years ago coincided precisely with the megafaunal collapse at the end of the Pleistocene. Climate change eliminated much of the habitat connectivity that allowed wide-ranging predators to maintain genetic connectivity across populations. Human hunting removed prey species faster than they could reproduce, creating trophic cascades that devastated carnivore populations. American lions, requiring enormous territories and abundant large prey, couldn't adapt quickly enough. By the start of the Holocene, they were gone entirely, outlasted by humans who had greater behavioural flexibility, more diverse diets, and the ability to adapt technologies rapidly to changing conditions. The largest cat in North American history vanished, leaving behind only fossils embedded in ancient tar and perhaps cultural memories in indigenous traditions that speak of great cats that once ruled the land before the people learned to master fire and stone.